Okay, hi everyone. So moving on, let's talk more about experiments. Uh, so so we've kind of talked about the basics of experimental design and more in terms of what they can actually tell us, and what they can't tell us, or rather, kind of the advantages they have over correlational designs, mainly that you can actually infer causality from an experiment, but you can't from a correlation. Okay? So with that said, though we've kind of covered that, there's a lot of different variations on experiments that you can do, and they each have their pros and cons, which we'll talk about. So that's what we're going to go over today: is more specific experimental designs, um, such as between versus within subjects, match subjects, and again, the pros and cons of each. Okay. So just kind of a refresher. Remember that when you have an experiment, you're going to have at least two levels or two conditions of an independent variable. Right? Hopefully you remember this, but remember the independent variable, that's the thing you manipulate, the thing you change to see if it has an effect on what you're measuring, which is the dependent variable. All right. So if I wanted to know what study strategy is best for remembering words, the independent variable is going to be study strategy. It's going to have at least two conditions, and then dependent variable might be how many words they remember. Okay. Remember, we have things like extraneous variables, common in every experiment. Um, Extraneous variables are any kind of individual differences that can add some fluctuation to your results, but should get canceled out due to random assignment, but not perfectly. So, for example, variable environmental conditions across the course of the study. Um, let's say that you test some people in the morning and test some people at night. Well, people might be more attentive or less attentive depending on the time of the day. As long as you equally distribute that across conditions, it's fine, but it is going to add a bit of what we call noise to your results. Um, Kind of the biggest one when it comes to extraneous variables is individual differences among participants. So let's say I was looking at cell phones and driving, and I ran an experiment on that. Well, baseline driving ability, whether they're a good or a bad driver, is going to fluctuate by person, right? There's also, lastly, fluctuations in the kind of physical or mental state of an individual participant. And, you might, well, this kind of goes off of the example. Like, this is also kind of the example I gave earlier of maybe testing some people in the morning when they're in a good or a bad mood, and then testing some in the evening when they're in a different mood. Um, so something to that effect. Right? Again, all these things are going to add noise to the experiment. So they're going to add some changes to the dependent variable that um, is not what you were, and not being changed by your independent variable. Um, and just a reminder, because this is very important, remember there's a difference between extraneous variables and confounds. So an extraneous variable is going to be um, anything that should be about equal across conditions. So some uncontrolled variable, but that should be equal across conditions. Confound, remember, is an extraneous variable, but it varies along with your independent variable. Okay, so to give you an example, let's say I was looking at some sort of memory test, and whatever the independent variable is, say study method. If I test some of the participants in the morning, but I test some at night, that could be either an extraneous variable or it could be a confound. It would be an extraneous variable if it's randomly mixed along with the independent variable. So let's say, in addition to testing people under one strategy versus another strategy, let's say 50% of strategy 1 is in the morning and 50% is at night, and then 50% of the other strategies in the morning and 50% is at night, that's okay, right? Because what would that result in? Well, yes, the study time could add a bit of variance in your results, but it's equal across conditions, right? In contrast, um, if you only tested, let's say, if you tested strategy 1 only in the morning and strategy 2 only at night, well, then it's a conflict, right? Because now we don't know, is it your study strategy manipulation that's causing an effect, or is it the fact that that's also varying with the time of day you're testing? Just another little refresher there. Okay, another thing refreshing to refresh you on with experiments is how we phrase our hypotheses. So remember, with correlations, we're just looking at the association between two. Well, we've dealt with two, but it could be more than two. But generally two variables. And your hypothesis is either there's going to be a positive relationship or a negative relationship between those two variables. In contrast, remember with experiments, our hypothesis is going to be um, it's going to be directional, and we're going to say participants in condition A will score higher on the dependent variable than participants in condition B, okay? Or will be more likely to demonstrate said behavior than condition A, whichever condition you think is going to be higher, all right? So that's how we present hypothesis when it comes to an experiment. Okay. So a couple more review points. So yeah, hypothesis is going to be phrased as a comparison between conditions, and what you compare is the means of the dependent variable for each level of the independent variable. To put that more simply, I would say if I was running two conditions, two memory strategies, I would compare the dependent variable, the mean score for one condition versus the other condition. Okay. And then we, of course, perform stats to see if the difference is significant. More on that later. Okay. So that should all be review, but when it comes to experimental designs, a big question is which particular experimental design are we going to use? And there's two, well, actually three options here. But I'd say two are most common: between subjects designs and within subjects designs. Okay. So a between subjects design, this is when you have different participants do each condition. Okay. Contrast, in a within subjects design, you have the same participants do all conditions. Okay. So let's say I was looking at cell phones and driving again. That's kind of our common example. One way I could do that is I could have, say, 10 people use the driving simulator while talking on their cell phone, and have 10 people use the driving simulator while not talking on their cell phone. Okay, that would be between subjects because I'm using different people for each condition. Okay. On the other hand, and this is probably more often done, I'd say cognitive psychology, you could have the same people do multiple conditions. So you could have the same people be tested while in the simulator while using a cell phone and then without using a cell phone. Okay, so repeated testing of all individuals. By the way, I don't know why we can't agree on terminology here. Psychology is a field, but within subjects design will sometimes be referred to as a repeated measures design. They're the same thing because you're measuring people repeatedly in multiple conditions. Okay. And as we're going to see as we go into these more, they each have their pros and cons, and as always, it depends on your research question and the nature of your experiment. Okay. So kind of the simplest method for running an experiment, I guess you could, well, the simplest would be to use a between subjects design, specifically a randomized design. So again, you're going to have your independent variable thing you manipulate, and it's going to take on different values called levels, conditions, groups, or treatments. Okay? Those all kind of mean the same thing. Now, when we run actually any of these experiments, whether it's within subjects, between subjects, or matched design, um, well, we'll start with just single factor design. This is when you only have one independent variable, okay? One thing that you're manipulating. Here you're going to have at least two groups to make, you're going to need at least two groups to make it an experiment, okay? So it's not an experiment if you only have one condition, because there's nothing to compare to, right? So if I'm just looking at one memory strategy, then it's not an experiment. I'm comparing two groups with two different memory strategies, and I manipulated it, then it's an experiment. Now, the key assumption behind that we've kind of touched on already, behind a between subjects design, is that you're going to randomly assign people to conditions. Okay. So each participant has an equal chance of being placed in each group or each treatment or each condition. Okay. Um, there's plenty of ways you can do this. As long as it's random, it doesn't really matter. So you could say have every go by order and have every every odd numbered participant do the first condition and every even numbered participant do the second condition. Right? That would be random, like numbering people off. It wouldn't be random if you say had the first group, say all the people that showed up earlier do the first condition, and all the um, people in the who show up later do the second condition. That would be a confound because you're not randomly assigning people. Um, there's many other ways you could roll a dice, you could flip a coin, you could sometimes just in a program or a survey, it will randomly assign people for you. So again, as long as it's random, it doesn't really matter which method you use. Um, so a key assumption with a between subjects design is that we're going to have random assignment is going to make the groups equivalent, or at least very close to equivalent, on extraneous variables. Okay, let that sink in. Write that down for sure. Okay, so when we randomly assign people, we hope to make groups equivalent on extraneous variables. Okay. So again, let's look at the example of um, driving and cell phones. Now, if we randomly assign people to conditions, so cell phone versus no cell phone, there is a possibility that um, we might end up with more good drivers, just baseline good drivers, in one condition than the other. But the chances of that are pretty low, and this kind of goes hand in hand with the statistical tests, which we'll get to later. But we would expect, because we're randomly assigning people, that there should be an equal amount of good and bad drivers in both conditions, right? Because you're randomly assigning people, so it should even out, especially if you have a good size sample. Right? And that's again going to be the case with every experiment. We're hoping that because we're randomly assigning people, we're going to even out those extraneous variables among conditions or among groups. So let's say I wanted to look at, again, a memory technique or a memory strategy Well, if I randomly assign people, there is the exchanges variable of some people trying harder, some people paying more attention, some people caring more, whatever it might be. But that should be about equal across conditions because we're going to randomly assign people. So whenever you have, so one thing to be clear though, is that when you have a single factor, you can still have more than two levels. So when we say a two-group design, this is kind of the simplest kind of experiment you can run because you only have one independent variable and it only has two levels. Okay, so make sure you're clear on that. Is that the number of well, actually we'll get to, I think we get to this later, but one independent variable can take on more than two levels. Okay? So let's say I wanted to, so one independent variable again can take on two or more levels, depending on how you structure it. So I could have the one independent variable of distraction type. I was again looking at cell phones and driving, but that could take on three different levels. Maybe I wanted to compare no cell phone to talking on a cell phone to texting, right? That would be no longer be a two-group design. Now we have three groups, obviously, three conditions. Um, and whether you have two conditions or not, so again, your independent variable can take on two or more levels or have two or more groups if you want. And this, of course, can be very useful. Sometimes we need more than one comparison. Um, it all just depends, as always, on your research question at hand. So say I wanted to look at caffeine consumption and speed of encoding, how well you can remember something. Well, maybe I want to look at, maybe I don't expect that a little bit of caffeine is going to have an effect, but a lot of caffeine will. Well, the simple way to look at that would be to, again, one independent variable, but that independent variable can have three conditions or three levels. So no caffeine, low caffeine, and high caffeine. Right? And then in addition, so you're adding that third third condition, but really all the logic is the same as with a two-group design. So you're going to take the mean, say number of words recalled for the no caffeine group, and then you're going to take the number of words recalled mean low caffeine and then the high caffeine. And we can compare these. All right. That's about it for between subjects designs or between groups designs, where again, you're randomly assigning people, you're having multiple groups, multiple different people do different conditions. However, an alternative to that is what we call a matched design. This is a between kind of a different type of between subjects design, but it allows us to cut down on extraneous variables. So if you kind of think about it, right? I mean, the whole idea behind between subjects designs is that random assignment should even out those extraneous variables, right? People who care more, try more, people who are good or bad drivers should be about equal across conditions. Well, that often is the case, but it's no guarantee, right? And it actually does affect our ability to kind of observe an effect, right? So without really going into statistical power, which is another topic, basically we kind of talked about how we want to cut down on extraneous variables if possible. So, if we're looking at a memory test and we basically give people more freedom, allow them to study whenever they want or however long they want, that's going to add some extraneous variable, right? Better, it's not as ideal as when we have control over all those factors. So with that in mind, sometimes what will be used is what's called a matched group design. And in this situation, you are, well, I don't want to say guarantee, but um, at least should be equal on the characteristics you use for the match. Okay. So the way a match design works is, again, it is still between subjects, but it doesn't have all the negative things, some of the negative things of a between subjects design, but it also has its cons. So the way it happens is you recruit a sample of participants and you measure the participants on the extraneous variable that you want to control. Then after that, you're going to group participants who scored the same or at least very close on the matching variable. And then you randomly assign people in the match groups to each of the conditions. Okay. So here's kind of what that looks like. Just visually. So let's say the different color is, for whatever reason, our extraneous variable. Well, if I'm randomly assigning people, you can see, kind of imagine how it's not going to end up perfect, right? Especially with a small sample size, you might end up with a lot of reds, whatever that represents in one condition, not so much in the others. So it's not a perfect system. Randomly assigning people, ideally, you know, would make all extraneous variables equivalent, but in reality, it doesn't. On the other hand, with a match design, what you're doing is you're kind of checking that variable, and then you're going to kind of match people, as the name would imply, on that variable, and then split them up. So again, just speaking hypothetically, let's say the color of the circle is our extraneous variable we want to control. Well, I can have, say, measure the circles based on their color, and then I'm going to assign them based on that characteristic. Let me give you a more real world example. So now, actually, we'll come back to that in just a second. So let's say I wanted to test two different weightlifting programs. So I wanted to compare what's going to make people stronger. Lifting heavier weight at a low volume, meaning you do fewer repetitions, or a heavier weight, or so a higher weight at lower volume, meaning less repetitions, or a lighter weight but at higher repetitions, meaning you do more of it. Well, kind of a problem here is that there's the extraneous variable of um, how strong are people to begin with, right? Or maybe even how long have they been training before doing this experiment. That's definitely an extraneous variable that we would want to control for. I mean, yes, that should even out with random assignment, but it's going to add a lot of what we call noise to the experiment. It's going to, probably not even out perfectly because it could vary so much. So kind of whenever you have an extraneous variable that can vary quite a bit, and also when you don't have a lot of people to do the experiment, those might be reasons to do a matched design. So here's what that'll look like. So what I'd have people do if I'm comparing these two weightlifting programs is see how strong they are to begin with. So how much can they squat? Okay. So I get that baseline measurement of how strong are they. That's all the numbers here. And then I'm going to pair them up based on that number. So see, participant 1 squatted 200 pounds or kilos or whatever. Participant 2 did the same with 3 and 4, 5 and 6, 7 and 8, so on and so on. So I'm going to pair them up based on how well they scored on that initial measurement. Okay. What I'm going to do now is actually split them up into the different conditions. So now that I've kind of paired them off based on their baseline score, now they each get the treatment. So participant 1 goes into the high rep condition, participant 2 goes into the low rep condition, 3 goes into the high rep, 4 goes into the low rep. Like we saw here, again, that's all based on their initial score of our measure. Okay. So now this way you can kind of see how we're kind of deliberately matching people. We are deliberately matching people based on um, based on an attribute that we can actually measure, and now we can ensure that baseline strength is going to be equal across conditions. Okay. And once we've done that, and once we've administered our treatment, so they're finished the program, now we're going to test them again. Um, and now we can compare, well, um, participant 1 did better than 2, 3 did better than 4, 5 is about the same, these are about the same, whatever it might be. But the advantage here is that we, again, because we kind of paired them off based on their initial score, we have a lot more of an ability to kind of see an effect because we know, well, okay, these two scored the same coming in, and that's why we paired them together. Yet participant 1 is getting stronger. The high reps condition is increasing strength more than the low reps condition. Okay? So that's what that looks like. And again, this is very useful when you have um, a lot of an extraneous variable that could have a big effect on your results. So let's just looking at this example again. If I just went in there and I compared just people randomly assigned, right, to either the high rep or the low rep condition. Well, what if one guy's a competitive power? What if some guys are competitive power lifters? Some people are, you know, um, novice lifters. Some people are in the middle. Maybe the one I'm testing, the squat, maybe that's something they don't do, right? Bottom line is it could vary a lot, right? You might get some guys squatting 200, you might get some guys squatting 500. That baseline score is going to have a pretty big impact on the results. And again, it should even out through random assignment, but it's so variable that it's not going to even out perfectly, right? So that's again where if we're really worried about this extraneous variable, just adding too much fluctuation, then we will often use a match design or a within subject design. We'll get to that in a bit. A couple more example or one more example. Let's say we want to look at um, some sort of doll and see how does it affect the aggression of children who play with it. Well, in that situation, um, some kids are of course going to be more aggressive than others to begin with. So if we wanted to equate for that, we could use a match design. Um, we could, conceivably um, give children a chance to play and just see, how aggressive are they to begin with. Once we see that behavior, we can actually pair them off based on, or sorry, this is the matched version. We can pair them off um, based on how aggressive they are, just kind of at base level without administering any kind of experiment or treatment to them. Okay. Again, once we know their baseline score, we can pair them up or put them into threes based on that score. So this is that's what that would look like. With a match design, it would look like this. With a non-match design, we're just going to randomly assign people. But again, that's not ideal because we're not matching them. We're not kind of controlling for that extraneous factor. One more thing to mention here is that with a match design, if you only have two conditions, it's the same logic, whether you have two or three conditions for your independent variable, but the only difference is that obviously you need three people to match if you have three conditions, four people to match if you have four conditions. Okay. So if going back to the lifting study, if I had, say, a third condition, a medium reps condition, well, I would need even more subjects that are going to match with each of these people on their baseline score. Okay. All right. So we've kind of talked about the advantage of a match design, but honestly, maybe it's just my field, but it's not really used that much. Because there are, of course, disadvantages to it. One reason it's disadvantageous is that it's not really possible to match people on every possible extraneous variable. Okay. So we might be able to match them on one extraneous variable, but not all of them, right? So let's go back to our example of weightlifting program. Well, I can match people on their baseline strength, and that will definitely help. But that doesn't mean I'm matching them on other factors, like say how responsive they'll be to the program. Maybe, one person is maybe these two are matched because they squat the same amount, but they squat the same amount for different reasons. Maybe this person squats 200 because he's never lifted before, whereas person two, maybe they squat 200 because they're older. So although we're matching them on one factor, on one extraneous variable, again, their baseline strength, that doesn't mean we can match them on other factors like, say, age, um, or just how responsive they are to training, or maybe how big they are, right? Again, maybe this person is like, a lighter person, they're only like 150 pounds, whereas this person is, say like 250 pounds. Well, I'd be very surprised if the bigger person, the 250-pound person, is not going to show more progress than the 150-pound person, independent of whether which treatment they get, right? So again, though we've matched them on their baseline strength, that doesn't mean we've matched them on other extraneous variables. Okay, again, like age, like experience, like size, whatever it might be, injuries, could be anything. Um, Kind of the other pro or other con of a match design is that it can take quite a few participants and it can take a lot of time. So if you're gonna, be measuring people both before and after a treatment, that's obviously more time. Um, for something like, say, a memory experiment, it's not really worth measuring them before and after. It's best to just measure them after. Just use either between or within subjects design. Um, and then kind of the biggest issue with a matched design is that um, you might not be able to match everyone. I don't know why that's not here. Sorry. Um, so let's say that, you know, um, if you, or sorry, I had that somewhere, but I'll just mention it now. You might find that some participants just can't really be matched at an acceptable level with others. So this is kind of like a perfect example of how we happen to get people that are perfectly matched in terms of their baseline strength. Well, what do you think happens when we don't have people that really match up? So we have one guy who's gotten 200, and then the other guy's 300, and then there's a 400 guy, 450, 350, and none of them really match on their baseline strength. Well, it doesn't necessarily have to be a perfect match, but it has to be pretty close. And if you can't find someone close enough to match with, well, then you can't really run the participant in a match design. If I get, say, only one person who squats 200 at baseline, well, they just can't, and there's no one else who squats 200 or close to 200 baseline. I can't really include them in the study because there's no one to match them. So that's another con of a match design. Okay. Um, then the last thing is that kind of keeping in mind that might take more participants because you have to try to match everyone, and it also takes more time just because have to do a baseline measurement. There's no guarantee that will even make a difference, right? It's certainly possible that the matching variable was really not that important. And if that's the case, you've kind of wasted time and statistical power. So an example might be, let's say I compare two people, on the squad, but it really doesn't matter what their starting point is. Let's say that doesn't stay their starting level of strength. Doesn't actually matter either whether they start at 400 or 200. Their response to the treatment is the same. Well, if that's the case, then there's doing a match design would just be a wasted effort. Um, I'll post this video just below this one, but again, matching to some degree guarantees that you'll at least kind of cancel out that one extraneous variable, the one you measure, but it doesn't guarantee that the other ones will be equivalent. So again, just to go back to an example, you might match people based on their baseline strength. Doesn't mean you're matching them based on experience lifting or age or other factors. Random assignment, is based on chance, but the more participants you have, the more likely random assignment will be good, and we'll even out those variables. And there's a video for that, so I'll stop here.